Welcome back to our system design series. In this episode, we are going to dive into distributed messenger queues, a powerful tool for decoupling services and enabling scalability in modern applications. By the end of this video, you will understand what distributed messenger queues are, why they are crucial for building scalable systems, and how they can help ensure reliability and flexibility in your application. So, imagine you are building a complex application where multiple services need to communicate with each other. For example, a payment service, an inventory service, and a notification service, for example. If these services talk directly to each other, it can create tightly coupled system that's hard to scale and maintain. This is where distributed message queues come in. They allow you to decouple services, making your architecture more resilient and scalable. So let's take an example to look at how to look on how distributed messages looking are. So we will have like a service. Let's call it a producer. Producer, and let's call it producer one. Let's say that we have multiple producers. Okay, and they will send requests through message queue. Let's change the okay, let's make it like that. And if I made it, I guess, and let's make all the color for it red. So they will send the request through the message queue, and we have consumers. Let's copy this one, and let's say that we have a consumer. And this consumer will pull these messages from the message queue. So by this, we enabled asynchronous communication. Let's make a different color. Let's add another one here. And last one. Okay. Let's say that we have consumer 1, consumer 2, and consumer 3. So a distributed message queue, as you can see, allows for asynchronous communication between different parts of the system by sending messages between producers and consumers. They help decouple services, ensuring that even if the consumer is unavailable, the producer can continue sending the messages. Okay, so if we're trying to understand this one, like imagine you building a complex application where where we're like where we have multiple services are communicating with each other. So the older service, maybe notification service, and multiple services, and instead of them connecting with each other directly, this will be quite tough. We enable asynchronous communication with message queue, so the service could send a message to the message queue, and the other services could pull this message from the message queue. So this decouples the services from each other, which means that they can operate independently. If one service is down or slow, the rest of the system can continue functioning at the messages as the messages are held in the queue until the recipient service is ready to process them. So we can, I guess, by far right now, I guess we know what is a message queue. A message queue or a distributed message queue is a system that allows different components of an application to communicate by sending messages through a centralized queue. And instead of having services directly communicate with each other, they send the messages to the message queue, which then routes those messages to the appropriate recipient. Okay. Um, we might ask ourselves another question, like how does message queues actually work? So um, we have services that are producers, which are produce the message. We call them producers because they produce the message. Called producers send the messages to the queue. Okay, send the messages to the queue. Other services, which called the consumers, then read those messages from that queue and process them. The queue acts as a buffer ensuring that messages are delivered even if the consumer is temporarily unavailable. So this mechanism allows for asynchronous communication between services, which is especially useful when processing tasks that take long time, such as generating reports or sending bulk notifications with a distributed queue. Producers can continue sending messages without having to wait for consumers to process them, which improves the efficiency and responsiveness of the entire system. So if we right now we know what is the message queue and also we know how it works, we need to know what is the benefits from using a message queue. The first thing is decoupling services. By using message queue, you can decouple different parts of your system, making each component more independent and easier to maintain or replace. The second thing is scalability, because distributed message queues help scale systems by allowing multiple consumers to process messages concurrently. You can easily add more consumers to handle increased load. Lastly, fault tolerance. Message queues are stored in the queue until they are successfully processed by consumer, providing fault tolerance. If a consumer fails, the message remains in the queue, ensuring that no data is lost. And lastly, load balancing. Multiple consumers can process messages from the queue effectively balancing the load across different services and ensure that no single service become a bottleneck. A real world example of a message queue is Apache Kafka, is a popular distributed message system used by companies like Uber to handle millions of rides events in real time. And Kafka's, I guess, it's the most famous one. The most there is a RabbitMQ as well, but I guess Kafka is the most important one and the most used one in my opinion. So, to summarize everything, a distributed message queue are a powerful tool for decoupling services, improving scalability, and ensuring fault tolerance in your system design. They enable asynchronous communication, which helps build resilient and scalable systems, especially in complex architecture with multiple interacting services. If you enjoyed this video, don't forget to like it, subscribe, and hit the notification bell so you'll never miss any video. And see you in future videos.